We'll give you everything you need to know about trig in one quick deal, but it will also, let's see if you can, everything you need to know about trig, but it will also, I will give you another page that you can take your notes on. It emphasizes the part that it's important to the vantage point of where the angle, what we're looking at, you will name that side. Now notice none of the right angles are marked on these right triangles. So naming that side, sitting from the opposite of the right angle is the hypotenuse. Sitting way far away from whatever your angle is looking at is the opposite leg. And that brings us to the leg that is right next to whatever angle you're looking at. It's called the adjacent leg. So from this, test yourself, hypotenuse. This next to the angle, adjacent. This one across from the angle, opposite. Hypotenuse, opposite, adjacent. Hypotenuse, adjacent, opposite, opposite, hypotenuse, 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 adjacent, hypotenuse, hypotenuse, adjacent, adjacent, opposite, hypotenuse, opposite, adjacent, hypotenuse, adjacent, opposite, hypotenuse, opposite, opposite, adjacent, hypotenuse, hypotenuse, adjacent. Now from the right angle, both of those are adjacent. Hypotenuse, adjacent, opposite, hypotenuse, opposite, adjacent, opposite. So now we're getting to the trig ratios. Sine equals the opposite leg over the hypotenuse. Cosine equals the adjacent leg over hypotenuse. Tangent equals opposite leg over adjacent leg. Sine, opposite over hypotenuse. Here's tangent, opposite over adjacent. Okay, if he's standing here, what's the sine? Well, we need opposite over hypotenuse. So from the person, this is opposite, this is hypotenuse, that's the two we need. From cosine, we need adjacent over hypotenuse, adjacent over hypotenuse. Tangent, we need opposite over adjacent, opposite over adjacent. Cosine, we need adjacent over hypotenuse. Tangent, we need opposite over adjacent. Sine, we need opposite over hypotenuse. Cosine, we need adjacent over hypotenuse. Tangent, we need opposite over adjacent. Sine, we need opposite over hypotenuse. We don't just do this because we like the names. We do it because it lets us figure out the numbers. So, standing here, we need sine, so we need opposite over hypotenuse, which is 5 over 13, opposite over hypotenuse, or 0.38. Cosine, we need adjacent over hypotenuse, or 12 over 13, which in decimal is 0.92. Tangent, we need opposite over adjacent, 5 over 12, 0.42. If he's standing here, cosine, adjacent over hypotenuse, 4 over 6, 0.67. Tangent, we need opposite over adjacent, or 5 over 12, which is 0.42. Sine, we need opposite over hypotenuse, or 1,350,000 over 2,450,000, or 0.55. Cosine, adjacent over hypotenuse, 19 over 12, 0.86. Here, when they're all listed, sine, we have to find which one is opposite. 5 over the 13. We ignore the 12, extraneous information. 0.38. Cosine, same numbers, same locations, but this time we need adjacent, or 12 over 13. Tangent, the extraneous information is the hypotenuse, so we need 5 over 12. Standing here, what's tangent? Opposite over adjacent. This time, it's 12 over 5. Standing sine, we need opposite over hypotenuse, so we need the 1,350,000 over 2,450,000. If we know the angle in a calculator, we can figure the rests. So we put cosine. Why did we choose cosine? Because this is adjacent, this is hypotenuse. Adjacent over hypotenuse, x over 12, is the cosine 42 over 1. You cross multiply and solve. If you know the angle, well, what is this x? Opposite. What is the 12? Hypotenuse. Opposite over hypotenuse, sine. Sine 48 over 1, and sine 48 you can put in a calculator and get a decimal, cross multiply and solve. Sine 48 over 1 equals x over 12, cross multiply. 12 times sine 48, 8.9. Cosine 48 over 1 equals x over 12, cross multiply, and we get 8.0. That's this part.